Hello, and welcome to your homework for Tuesday or Wednesday night, depending on when I see you in class. Your homework for tonight is to review the quadratic formula. Now, the quadratic formula is something we learned about in Algebra 1, which is why we are not spending a full day in Algebra 2 reviewing it, and instead are using notes and a guided video to help us remember what the quadratic formula was. So, up at the top of your notes page, you will see a warm-up problem. So the first thing I would like you to do is to list out for me all of the different methods that we currently know for solving quadratic equations that look like ax squared plus bx plus c equals 0. So go ahead and pause the video, take a minute to list out the different methods that we know, and then press play when you're ready to continue. All right, let's see what you came up with. So the first thing I would check for is, do you have graphing calculator? The graphing calculator is one method that we can use to solve equations like this. In our graphing calculator, if we graph our quadratic function and we ask the calculator to find or calculate zeros, also known as x-intercepts, our calculator will solve this equation for us. Now, if we don't have a graphing calculator, we're going to have to rely on an algebraic technique. And probably the next one I would think of is factoring. Factoring should be our go-to algebraic process. Out of all of the algebraic processes that we have, factoring is going to be the most efficient, so it should always be the one that we try first. Now, the only unfortunate thing about factoring is that it doesn't always work. There are some quadratic equations that just can't be factored with whole numbers, or maybe can't be factored at all. So if factoring doesn't work, I move on to my next algebraic technique, which is completing the square. So completing the square is a technique that we learned about on Monday. The nice thing about completing the square is that it will always work, which is nice. The downside to completing the square is it is a little bit more time consuming, right? Remember how much longer it took for us to complete the square than to factor. Now, the final one, which maybe you thought of based on the notes title for today, is the quadratic formula. So the quadratic formula is another one of these techniques that will always work. If you couldn't factor something, but you still needed to solve it algebraically, probably my second best option would be the quadratic formula. So I would try factoring first, I would try the quadratic formula second, and then maybe I'd rely on completing the square if I was asked to do it. All right, so let's go ahead and see if we remember what the quadratic formula was. So you'll notice I left a little space for us to fill in the quadratic formula. It's possible you might need to sing the song to yourself, or maybe you just know it. What I would point out to you is that the way the quadratic formula starts out is I have to have an equation in standard form, and it has to equal 0. So I'm going to make a little note of that. Has to equal 0. If my equation doesn't equal 0, the first thing I need to do before I start using the quadratic formula is make it equal 0. So if I have a standard form equation that equals 0, then the quadratic formula says that x equals, my solutions are negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. The a, the b, and the c are the coefficients in my equation, a, b, and c, and all we have to do is plug them in. So let's practice now actually plugging these things in, and we're going to try to do a couple example problems together. So look at this first example problem. Can we solve it using the quadratic formula? The first thing I like to do is actually identify what is a, what is b, and what is c. Now, you don't have to do this, but I think it's helpful later on when we start plugging into the quadratic formula. So if I look at my equation, it looks like a was 3, b was negative 2, and c was 7. So my solutions to this equation should be x equals negative b, so that's 2, plus or minus the square root of b squared. Now notice that negative is also being squared because b was negative, minus 4 times a, which was 3, times c, which was 7, all over 2 times a, which was 3. Now, once you've plugged in, it's going to come down to simplifying. These problems are almost always going to be no calculator. So let's see if we can start simplifying. I'm going to keep the x equals 2 plus or minus square root, but I'm going to start filling in the inside. So I know that negative 2 squared, that's really 4. When I see 4 times 3 times 7, I could do 12 times 7, but I could also do 21 times 4. And I think 21 times 4 seems a lot easier to come up with 84. If I simplify further, now I have 4 minus 84. So the inside of my square root is really negative 80, all over 6. Now it may look like we're done, but we want to keep simplifying. So the next thing I want to try to do is take this negative 80 that's inside the square root and see if I can simplify it. So I like to start thinking of what are factors of negative 80. I try to think of ones that are perfect squares so that I can take the square root. So the first thing I think of is 16 and 5, and of course that negative 1. If I break up my, my square root, I'll kind of show you how I would do it. I would write this like plus or minus the square root of 16 times the square root of 5 times the square root of negative 1 all over 6. Now I know the square root of 16 is 4. I know the square root of negative 1 is I. So if I keep writing, I've got x equals 2 plus or minus 4i root 5 all over 6. Now we're still not quite done because we should be able to break this up and notice the real part and the imaginary part. So my real part would be 2 over 6, which we may come back and simplify in a minute. My imaginary part is 4 root 5i all over 6. If I simplify by getting rid of common factors, the 2 6, well, I can take out a 2 from each one, and I get 1/3. From the 4 6, I can take out a 2, and I get left a 2 on top and a 3 on bottom. The root 5 is still there, and my I is still there. So there are my 2 solutions to the quadratic equation. They were both imaginary, but that's okay because I know that quadratic functions must have 2 solutions, whether they're real or imaginary. So now I'm going to let you try part B. So go ahead and pause the video, spend a couple minutes trying part B, and when you pull the video back up, I'll have the solution written out and we can talk about it really quickly. All right, so I've worked through the problem for the most part, but I do want us to talk through the very end. Now, just to kind of set up the original problem, I would make sure at the very beginning that your equation equaled 0. It has to equal 0 in order for us to use the quadratic formula. So once I've set it equal to 0, I've identified A as 3, B as negative 4, C as negative 9, and I go plug into my quadratic formula. Inside the square root, I ended up with a positive 16 plus 108, which gave me 124. Now from here, we want to keep simplifying. Remember on the last problem, we looked at all of the factors of 80, and we tried to find factors that were perfect squares. Now I can't immediately think of factors of 124 that are perfect squares, so I'm going to start by thinking about dividing by 2, because I at least know it's divisible by 2. So if I divide it by 2, I get 2 times 62. Now, neither one of those are perfect squares, but I know that 62 is still divisible by 2, and I get 2 times 31. which means that one way for me to solve or rewrite this equation is to call it the square root. So let's go ahead and write it out. 4 plus or minus the square root of 31 times the square root of 4. So I took my factors of 31 and 4. 4 times 31 is 124, all over 6. I know that the square root of 4 is 2. So if I rewrite, I get 4 plus or minus 2 root 31, all over 6. And the square root of 31 can't be reduced anymore, so that's how I have to leave it. But I do want to break up and look at my real part and my imaginary part. So I get 4 6 plus or minus 2 root 31 6. And now I get to simplify even further. So I get to take 4 divided by 6, which we already did over here. It was 2/3, plus or minus 2 divided by 6. We also already did that. It was 1/3. I still have the root 31 on top, and there's my final answer. These two happen to be real solutions, but I had 2 of them because it was a quadratic. So that's it for your homework for tonight. Tomorrow, we will quickly go over the quadratic formula again, but I hope that after today, you're feeling pretty good about it. See you on Thursday.